Ross has a BSc in agriculture and a MSc in soil science from the University of Alberta. He's got a PhD from the University of Saskatchewan in soil fertility and chemistry. From 1982 to 2013, Ross led the Agronomy Research Program across Alberta with ARD. He specialized in soil fertility and agronomic research with dryland and irrigated crop production. From 1993 to 2013, Ross was an adjunct professor at the University of Lethbridge, and he taught fourth-year soil management and irrigation science classes, actually both of which I took with him. So if you can all please help me in welcoming Ross Mckenzie.
In the back? I guess you can now, you poor bastards. Unlike the speaker just before coffee, Drew, he talked about his good looks and wanted to make sure you guys could see his good face. Unfortunately, I have a face that only a mother would love. So I'll kind of stand behind here so most of you can't actually see me. Now I see Rob Dunn and Terry Dorn. I was sitting with them a little earlier, and they were commenting that, actually now that I'm retired, I've been retired for about 3 months, and they were kind of commenting on, is this a beer belly or a wheat belly? And I have to admit, I do like to support the barley growers, especially the malt barley growers and the wheat growers. But then Don Wentz came along. He says, no, that's neither one. That's a baby bump. And he said, you heard how Mckenzie got screwed by Alberta Agriculture, didn't you? It's maybe slowly catching on. Anyway, is there any Alberta Agriculture managers here? Probably they're too scared to put up their hands. They know I take them up backside and explain things to them. Anyway, so in case you haven't realized, I didn't leave Alberta Agriculture on the best of terms. They wanted me to sign documents, kind of like being like a Mike Duffy, and wanted me to sign things that weren't really true. So I thought, well, I think I'd rather just retire instead. But don't confuse me with Mike Duffy. There's 3 distinct differences between Mike Duffy and me. Number 1, I'm skinny and he's not. I've got hair. And number 3, I'm honest. So, anyway, enough of that. When Ken asked me if I might be kind enough to come and talk, and with the past histories of farming smarter and kind of some of their past traditions, they spend a lot of time, previous people, on soils and soil conservation. So we thought we'd just actually have this talk kind of maybe focus a bit more on soils past, present, and future. So that's really what I'm going to be talking about today. So really what I want to talk about are kind of start off a little bit on the history of the soils in Alberta, then talk about soil survey. Some of the notable soil science research has actually taken place across Alberta, but to kind of focus on southern Alberta, and talk about some of the impacts of agriculture, industries, and urban and rural expansions on Alberta's landscapes. And then just to give some of my comments on really where I think we should be going in the future with soils and crop research. So maybe we'll kind of back up about 10,000 years. And we all know that pretty much all of Western Canada, and matter of fact, most of Alberta, and pretty much all of Canada for that matter, was really covered by a glacial ice sheet. And then from 10 to 12,000 years ago, it took about 2,000 years for that glacial ice sheet to retreat. And then from that 10,000 years ago to now, then our soils actually formed and developed. So kind of really what was left behind after 10,000 years after the glacier was melted, we had a kind of a variety of landscapes. And really we actually wound up with a real range of materials on which the soils have actually formed. So I thought, just from an interest standpoint, it'd be kind of nice to know what are those different kinds of parent materials that we actually have that we're actually farming. And so really when we kind of stop and think this would be the landscape, but as the glaciers were melting and retreating, we were kind of left behind with very rough, rolly topography in some cases that we call that hummocky moraine. Other cases we call that glacial till material ground moraine. But it's interesting to know, or it's important for farmers to know what kind of parent material in which your soils have formed. If your soils have actually formed on glacial till materials, odds are you could probably benefit far more so from variable rate fertilizer application than if you're on other types of materials. And then when these glaciers were actually melting and retreating, you have to remember these glacial ice sheets were a mile thick, so there's massive amounts of water. That's why it took 2,000 years for the glaciers really to melt and retreat. And so as these glaciers were actually melting, the first things that would pour off these glaciers were the sandy material. So we call that outwash. So Fort McLeod would be a good example where we'd find outwash, a very sandy, gravelly material. Then as the water would start flowing away from the glacier across the landscape, then the kind of the loamy sand, sandy loam materials would be deposited. So very sandy types of materials. And when you're driving from, say for example, from Tabor to Bow Island, north of Highway 3, close to the Old Man River, those would be excellent areas that would be actually outwashed, or sorry, not, some of it would be outwashed, but some would be what we would call fluvial materials, very sandy materials. Then as the water continued to flow, but flow more slowly, then finer materials would start to settle out. We would call that fluvial lacustrine. And finally, in the lower areas where water would just actually stand still for a period of time and form glacial lakes, then that's really where the clays or the clay materials would settle out. So Coaldale would be a good example, or say east of Pincher Creek or the Raymond area. These are old glacial lake beds, tend to be fairly high in clay, relatively stone-free, very uniform topography, and probably really wouldn't benefit from very great fertilizer application, but they tend to be quite uniform. And actually that would be the same, really, the story too. If you're farming soils like that are fluvial lacustrine deposited, probably they're not going to be very much variation, probably not much need for variable rate fertilizer application. So in many ways, it's very useful to know what kind of materials you're actually farming. So this is just a soils map of Alberta. And so we have across the province just a real range of different types of parent materials that have been deposited. But then we have the influence of climate and how the different soils have formed across Alberta. So we have the brown soil zone around Medicine Hat and Oyen, very dry, short prairie grasses dominated for 10,000 years, not very much organic matter added to the soil, so not that much soil profile development. We move over to Lethbridge, kind of the Drumheller area, that's the dark brown soil zone, kind of more mixed fescue type grasses that were growing, predominantly mixed grasses. Added more organic matter because we had a little bit more precipitations over 10,000 years, more organic matter added to soil. Those soils were just tended to be a little higher in organic matter, like I said, better structure, better development, and a little more productive. Then as we start to move into central Alberta, we run into thin black and black soils. And there we saw predominantly rich fescue grasses growing, a lot of organic matter added because much higher rainfall, lower evapotranspiration, so much better soil development, very rich. These are what we call our #1 soils in Alberta, the black soils. Then as we continue to move north, then we're running into more tree-type vegetation, deciduous and coniferous trees. And then we get, these tend to be, really add a lot of acidic materials to the soil. And then this is where we have our dark gray and gray soils actually form. So we have a range of parent materials we have across Alberta, and then a range of climatic conditions. Then we have other types of soils. The technical name for them is solonetzic soils. And you can see this is really from Tabor all the way up to Vegreville is the dominant area of these solonetzic soils. They're characterized by high sodium and high clay. And the technical name I like to use for these soils are really crappy soils. They're good for grazing, but not good for cultivation. And that's just because they're marine shales, the original marine deposited materials, and reworked by glaciers, but the reality is they're just very high in sodium and not great to work with. So then as a result, we have lacustrine, fluvial lacustrine, sometimes we have veneer fluvial lacustrine over till, glacial till. We have a range of materials, and we have different soil zones. So then each of the different soils can be actually mapped and given a different name. We're actually very fortunate across Alberta that all of our soils have been mapped, and we have very, very good information. As a matter of fact, very forward-thinking soil scientists at the University of Alberta started mapping Alberta soils in the early 1920s. And Dr. Wyatt and Dr. Newton actually published the first soil survey of the Fort Macleod sheet, which covers the Lethbridge area, and they published that first report in 1925. And the last report number 56, was actually published about 16 or 17 years ago, 1996, by Bruce Walker and Wayne Pettipe. So that was soil survey number 56. That was the Gleason sheet east of Calgary. And so all of the agricultural areas in Alberta have been mapped. And so we have excellent soil survey information across Alberta. And the beauty of this is forward-thinking scientists in the last 15 years have then taken that huge database and actually put it into, they've digitized it, and it's actually called AgriSID, Agriculture Region of Alberta Soil Inventory Database. And so you can actually go to the Alberta Agriculture website and view this actual information right down to the quarter section basis. And it will actually tell you the landform, give you interpreted soil information, how was that soil deposited, what was the soil texture, and even giving you a land suitability rating. So we're very fortunate that forward-thinking people have been doing this. So you just have to go to the Alberta Agriculture website, and you just click on here, the soil information viewer, then you can just drill down to, you can actually input the township or an range that you want to look at, and drill right down. This is an example. This is Claire's home right here. I just kind of pulled that up as we're doing variable rate fertilizer on lamb farms on this particular half section here. But each of these areas that is designated by these black lines, all you have to do is click on that soil survey number, that soil unit number, and it'll give you very detailed information. And it'll give you exactly what you need to know. And as a matter of fact, if your land is kind of rolly, like in this particular case, it'll even tell you the soil type you might find on the hilltops versus the side slopes versus the lower slope and depressional area. So it's a very, very good database. Not detailed enough to do a variable rate fertilizer application, but give you very good information for your farm. So the first comment I really want to make this afternoon then is Alberta is very fortunate that the forward-thinking soil scientists over the last 75 years mapped all of Alberta's soils, and that information has all been digitized now, and you can look at it free of charge on Alberta Agriculture's website. So the next thing I really want to talk about is kind of the land we have in Alberta. And we can kind of divide the province into two distinct zones. There's the white zone, which is predominantly used for agriculture, and the green zone, which is predominantly used for forestry, oil, and gas. And there is some limited grazing on the fringe areas up against the white zone, but predominantly used for forestry, oil, and gas. And as a result, that green zone is the predominant area in the province. And so really about 60% of all of the land in Alberta is actually public land and owned by the provincial government, and about 40% of it is actually privately owned. So if you actually figure out how much land we actually have in Alberta, it's just under 159 million acres of land. So we have a very, very large database. But how much is that is actually used or suitable for agricultural uses? So we have 158.7 million acres of land. Of that, only 52 million acres is actually used for agriculture. Then we can kind of further divide that down. About 20 million is actually used for grazing, and it's left in native pasture or it's improved pasture. And some of that is even controlled by public lands as well. So 20 million is used as native pasture, but another 7 million acres has been improved and developed as either tame pasture or hay. So that leaves us with 25 million acres. Now of that 25 million acres, typically about 23 million acres of that is crops through annual crops, and about 2 million acres of summer fallow each year. So of that 158 million acres of land, really only about 25 million acres is used for cultivated agriculture. That's only 16% of our entire land base. So the second comment that I really want to make and impress on you is a lot of people think we have vast amounts of land in Alberta, and we do. But we have a very limited land base suitable for cultivated agriculture, only 16%. And most people are unaware of that. So of that 16%, how much Class 1 land do we actually have? And that's using the Canadian system of land suitability rating for agriculture crops, specifically spring-seeded cereal crops. Of that 16%, how much is Class 1 land? Anybody want to take a wild guess? You know the answer, Rob, because you told me.
Terry said 0.
And the answer is, anybody agree with Terry? Well, about 3 or 4 of you. Well, you're all right. We have no Class 1 land in Alberta. A lot of people think we do, but we don't. Either we have soil limitations or climatic limitations, but we have no Class 1 land in Alberta. Our best land is Class 2 land. So here's a map of Alberta showing our best lands, which are Class 2 lands. Kind of the thin black soils east of Calgary, the black soils up around Edmonton, and kind of in through here, kind of the Stettler over to, yep.
Ross, where would you find Class 1 land?
You'd have to go to probably Manitoba to find Class 1 land. Because they have their elevations quite a bit lower than ours. They have black soils, their elevation is quite a bit lower. You know, our elevation is about 3,000 feet above sea level. Their elevation is around 750 feet above sea level at Winnipeg. So nothing really in Alberta and much in Saskatchewan. So this is where the Class 2 land is. And here's just a map showing southern Alberta. We can see again this area around Calgary, east of Pincher Creek, some nice lacustrine soils on the Indian Reserve, the Coaldale area. That's really where our Class 2 lands really are. And I want you to remember this because I'm going to come back and in a few minutes I'm going to talk about the Calgary expansion and where it's going to go. So what I want to do now is go back in history. I talked about the glaciers retreated about 10,000 years ago, and over the last 10,000 years our soils have been forming and developing. And really, when we look at the First Nations peoples, they really lived in harmony with the land for 10,000 years. And it's really only in the last 150 years we've seen dramatic changes on the landscape. I kind of go back to the days of David Thompson in the late 1700s. That's when things started to change. The Native peoples were still doing trapping and that kind of thing, the Hudson's Bay Company, but things were changing. And by about 1860, during Palliser's time, Captain Palliser, when he went through and I just finished reading a book about Captain Palliser. He wasn't a captain, that was a title he inherited from his father. It's always interesting reading history books and seeing some of the things that people do. But anyway, Palliser was actually quite brilliant in some of his observations. But things were really starting to change in the 1860s, 1870s, and by the 1880s, the native way of life was really changing. They were being moved on to reserves, and the white man was really starting to take over. And really between 1880 and 1900 is really when these very large cattle ranches moved into southern Alberta, and that really tended to dominate the landscape because the buffalo basically had disappeared by the 1870s. But the railway went through from Medicine Hat to Calgary in about 1885, and then that was great for the livestock industry because then they could ship cattle back east, but it also meant that settlers started coming west. And so between 1900 and 1920, this is really when we saw very dramatic changes on the landscape, and not just in southern Alberta, but across all of Alberta. And that's really when the plow was brought in, and we started to shift to cultivated agriculture. So really, for the last 100 to 110 years, we've actually been dramatically changing the landscape across Alberta. And really by 1920, the dominant cropping system was the wheat fallow rotation. And that was kind of identified at the Indian Head Research Station in around the 1890s. It was maybe the best rotation to use because it would actually allow storing soil moisture for the next crop year. That cultivation year, you kept all the weeds under control, organic matter would break down and release nutrients, and then as long as you had reasonable precipitation, you would get pretty good yields. The downside, though, was that there was no protective cover left on the soil, and the land was left prone to a wind erosion. So by the 1920s, and definitely by the 1930s, we really started to see very dramatic wind erosion events. And we also realized, the research scientists that were working started to notice that organic matter levels were declining, salinity was increasing, but the big problem was really wind erosion, not just in southern Alberta, but across the southern prairies and really across the Great Plains of North America by the 1930s. So pictures like this were not the least bit uncommon. They were very common, and particularly in the 1930s during that very, very dry period. And the impacts of wind erosion, well, they were huge in the 1930s. Because when you have wind erosion events, you're going to lose those important fractions of your soil, the organic matter, the clays, and the silts. The organic matter is an important storehouse of the nutrients, a lot of the nutrients in the soil. Clays really tend to hold most of the positively charged elements that plants take up. So it's the important part of the soil that was really lost during wind erosion. So the end result is there's a great reduction in soil productivity, reduced the yields, and ultimately economic returns to the farmer. This is a picture I took after the Granum fire in the 1990s. But you can see the non-erodible aggregates are left, the rocks, and just very, very devastating when you lose most of that valuable topsoil. So the worst events were really in the 1930s. There were some bad events in the 60s, and to a lesser extent in the 1980s. So the next comment I really wanted to make was the wheat fallow cropping system and cultivation resulted in very serious degradation on millions of acres in the 1930s in southern and central Alberta. But when we look at the wheat fallow system, and in southern Alberta, there was probably over 6 million acres that were very, very seriously eroded. They needed to be reclaimed. And some of the more fragile lands, particularly in the special areas, were literally abandoned in the 30s and then were returned to grassland, either seeded back to grass or the native grass had just moved back. And it was really realized in the 1930s that we really have to do something different in a way of dryland farming. And so researchers and innovative farmers really had to take up the challenge. And one of those people was Dr. Palmer, who worked at the Lethbridge Research Center from 1921 to 1953, and he passed away in '84. I actually had the privilege of meeting him. He was a very interesting fellow. And his actually nickname back in the 30s was Trash Cover Palmer, because he really promoted the importance of leaving a trash cover on the soil surface. And so he was a very innovative researcher. He worked with very innovative farmers like Charles Noble to practice things like strip farming and sub-tillage. And it was interesting, one of the things when I was reading about him, he was actually strongly criticized by Ottawa for his technology transfer. This wasn't something an Ag Canada researcher should do, and I thought some things haven't changed much between the 1930s and today. Yeah, Ottawa wouldn't want the researchers talking to farmers and taking advantage of some of their excellent work. But he was a very strong advocate for conservation tillage. And then another notable person was really Charles Noble, who, this must be Windows 8 because it kind of is jumping around. But he was really the one, and who is the father of the Noble blade. He did a lot of testing with it back in the mid-1930s, and by 1936 he had some good perfections developed, and by 1940 he actually had a machine shop in Fort Macleod that would actually build a Noble blade, which was very nice, would slice through just below the soil surface, cut off the trash, but leave all the stubble on the surface. And so really, the fifth comment that I want to make is that forward-thinking scientists and leading-edge farmers really led the way. You know, they adopted strip farming and trash cover farming using a Noble blade. And so by the 1940s, things really turned around from a soil conservation standpoint. But what I would like to do is just talk a little bit about what are the impacts. You know, we kind of think that most of our lands across Alberta have been farmed now for roughly 100 years, but what have been the implications on our soils? And we're very fortunate that there's rotation to the Lethbridge Research Station, one of them being rotation ABC. That's just a picture of it was taken in the 40s. The actual Lethbridge Research Center main building would actually be right here. This is the Jail Road, and this is Jail Lake. And right up against 43rd Street and the Jail Road is rotation ABC. Rotation A is continuous wheat. Rotation B, there's both phases, wheat and fallow. And rotation C is wheat, wheat, fallow. So you have all three phases. And it's been farmed like that. Those strips have been farmed like that since 1911. So that rotation's been going now for 102 years. There's other rotations like rotation U and irrigated rotation, which has also been going on now for over 100 years and is really providing some very interesting data. But some of the work that's been done, not only from these long-term rotation plots, but others, but basically they observed when using the wheat fallow system, the crop yields basically stayed approximately the same for the first 40 years after lands were broken. But then after about 40 years, yields gradually started to decline. And only if we fertilized could we get them back up. And so what would be the reason for that? Well, this is just a map of what actually happened with soil mineralization. So it just really showed in that first 40 years after land was broken, there was a huge flush of nitrate and nitrogen. And basically that was coming from the organic matter. The nitrogen was being released from the organic matter. And you know, people say, well, why did your grandfather not fertilize? And my grandfather never fertilized. He farmed in Saskatchewan, never fertilized at all from the 20s to the 50s. But why? Well, he didn't have to, because they were living on organic matter. And as that organic matter broke down and released nitrogen and phosphorus, they didn't have to fertilize. This is just the trend for that first 40 years in using the wheat fallow system, this flush of nitrogen. But what was the consequence? Well, this is the consequence. This is total organic matter in soil. If we call that 100%, say your organic matter is at 4%. Well, after about 40 years, you're here. After about 100 years, you're here. You've lost about half of our organic matter. And you've often probably heard people say, well, with farming, we've lost about half of our organic matter. But it's not just the organic matter. It's the plant residue forms, the actively breaking down humus, the slowly breaking down humus, and the passive fractions. Well, these are the fractions we lost. And this passive fraction takes 100 to 1,000 years to break down. It was about 40% of the total organic matter initially before land was broken. Now it's about 80% because those important fractions were really lost, and that was really mined away. So one of the big consequences is that we lost our organic matter and we lost our soil quality using that wheat fallow system. Now in 1970, a very forward-thinking scientist at the research station decided, well, they would start fertilizing those plots. So they left a strip with no fertilizers, started putting on about 45 kilograms per hectare of only nitrogen, 40 pounds or 40 kilograms per hectare of only phosphorus, and then nitrogen and phosphorus on all of those strips. And that was in 1970. Then in 1986, Henry Jansen came along, a new young scientist that replaced Urban Pittman, and he decided, let's have a look and see how soil organic matter has changed. And basically, from 1970 to 1986, in only 16 years, they increased organic carbon from 1.6 to 2%. And that's organic carbon, not organic matter. So that's a huge increase. That's a 25% increase just by using a combination of nitrogen and phosphorus on the continuous wheat plots. So that really showed that not only would fertilizer increase yields, it would also increase organic matter and improve soil quality. So the sixth comment I just want to make is early forward-thinking soil scientists, that establish these crop rotations were really thinking in the long term. And these long-term rotation studies have provided very, very useful information. I use these long-term plots both at Lethbridge and at Breton at the University of Alberta have to look at phosphorus cycling and phosphorus availability, and provided some very, very useful information. And we really need long-term cropping studies to educate us. And I know that the person who was supposed to speak to before me, Don Huber, or I guess it's Don Huber, he was going to talk about glyphosate. And one of the comments that I would make is that some people really poo-poo what he says, but there may be some validity to what he says, because we know when we apply glyphosate, it doesn't break down in soil. Soils like clays and organic matter tend to be negatively charged and absorb the glyphosate and tend to neutralize its effect rather than the glyphosate break down. So there could be some logic to what he says. Now, our soils have a very high cation exchange capacity, so we might be able to put on glyphosate for 200 years before we see a problem in Western Canada. But where he's from, where they have very highly weathered soils, maybe it is a real problem. So we have to, and long-term plots would really help us nail down some of these things. But unfortunately, nobody wants to fund research that's more than about 3 years old, and then that's up. But I did establish some long-term plots at the Bow Island substation in 1991, so they're still on the go. That's the only long-term rotation study in the brown soil zone in Alberta. I'll be curious to see how long it can persist. Will it survive longer than me? And now I hope to live to be at least 90, but I doubt if those plots will survive that long. Now, the next thing I'd like to do is talk a bit more about fertilizer management, because there's been a lot of lessons learned over the years. Really, in the past 50 years, a lot of fertilizer work has been done not only in Alberta but across Western Canada. And we really realized that it's very important to replace the nutrients we remove from our soil. If we want to be sustainable, we have to replace the nitrogen and the phosphorus and other nutrients that are being removed. And if we replace those nutrients, then we're going to maintain and improve the fertility of our soils. But if we do that, not only are we going to be increasing our yields and be economic, we're also going to see a great benefit from a soil fertility and a soil quality standpoint, because we can build soil organic matter. If we build soil organic matter, we're going to improve soil structure and soil quality. And here's just a picture of some of the people that have done very good soil fertility work in the past. The late John Harapik, Doug Penny, who I worked with Alberta Agriculture, Len Krasnelski, who developed the FIRM program, who still works for Alberta Agriculture. He's kind of one of the last survivors of the old soils group. Eric Bremer, that I did a lot of work with over the years, who works with Western Labs. Marv Nyborg, who worked with the University of Alberta. Rias Karamanis, who actually replaced John Harapiak, and then as Wesco was phased out into Viterra, and then as Viterra was phased out, and I'll look at Blair Roth and say, I was going to ask him how he was doing things with Viterra, but Rigas has now been phased out of that phase too, but he was a very good soil scientist, and I'll be curious to see where he winds up. And other people like Jim Robertson, the University of Alberta, and these people all work for Alberta Agriculture. Elson Solberg, Gary Coy, Dan Heaney, Don Laverty, but all these people are gone. And ask yourself now how many people are left doing soil fertility and fertilizer research. There's not one person focused on soil fertility research with Ag Canada. There's really nobody at the University of Alberta. There's a couple of guys that dabble and do a little bit of work around Edmonton. When we look at Alberta Agriculture, Len Krasnelski is not doing research, but he's involved. And then my replacement, Doon Pauly, he's really the only person in Alberta that's doing much in the way of soil fertility work. And that's only about half the time. But what we need to be doing is conducting fertilizer research in all soil zones across Alberta with all various crops, and looking at not only nitrogen, phosphorus, and potassium, but looking at things like sulfur, micronutrients, because we all know there's all kinds of things being promoted in the way of in-crop application, and I kind of shake my head like when I see foliar application of nutrients, and there's a lot of stuff promoted to farmers that are just pure, unadulterated nonsense. I was going to use another word, but I was controlling myself because I keep having to remind myself Alberta Agriculture actually had a lawyer on standby all the time when I was speaking to deal with issues. And actually, he was a hell of a good lawyer, because I wound up into being about 4 lawsuits in my career, and we did very well. But I'm on my own now, and I don't have a lawyer, and I don't have liability insurance, so I have to be very careful how I choose my words now. But But there's been a lot of good things done in the past. We developed a program called FERT 92 just for irrigated farmers. Then we evolved that into AFIRM, Alberta Farm Fertilizer Information Recommendation Manager. Len Krasnowski took it that next step. But unfortunately, we were not able to get any money to keep this updated in the last 7 years. And it needs to be updated. We've got a lot of good information that needs to go into that. And hopefully Trevor Wallace is a person who's going to maybe take that on and keep this program up and running for Alberta farmers. So comment number 7 then. In 2011, Alberta farmers spent almost $750 million on fertilizer. And that's huge. And you look at how much money is being spent on fertilizer research, it's precious little. You know, you talk to guys like Acidef and they think, well, yeah, we're throwing a bit of money at it, but that's it. They're throwing pennies at it when they should be throwing hundreds of thousands of dollars at it. Fertilizer has become absolutely essential for annual and perennial crop production. And well-managed fertilizer not only improves the profitability of Alberta farms, but really aids in improving soil quality. I don't want to end there on fertilizer, but I will talk about variable rate fertilizer technology. I think it's a great technology. You're all well aware of what it is, and the purpose is to really kind of optimize putting the right amount of fertilizer at the right time, in the right place, the right rate, but in variation on your land, depending on how your soils vary. So the more you understand about how your soils vary, the more you can actually utilize this. But some of you, depending on where you farm, your soils aren't variable enough to even need it, so you don't need this technology. And this is probably where I have one of my concerns, is the real clash between scientific knowledge and promotion and marketing. So if I look at a number of the displays here, some of it I think is, boy, that's pretty darn good marketing, but I really wonder where the scientific knowledge is to really justify their claims. And so examples, in-crop nitrogen fertilizer management, I think there's maybe a place for it in some cases. Variable rate fertilizer technology, I think that there's definitely a place for variable rate fertilizer technology. But there's a lot of great claims made that, again, I think they're just blown well out of proportion. All kinds of specialty fertilizers that make great claims on their efficiencies. The need for micronutrients and other types of fertilizers. There's all kinds of great claims being made, but very little research is being done with these products to really substantiate when they might work and when they might not, or in many cases they probably wouldn't work at all, or at least not provide you a financial benefit. And who's doing the research? Well, very little is going on, to be quite blunt. So comment number 8 then, sadly, there's a need for specialty fertilizer, new technology, or sorry, the need for specialty fertilizers and new technology has been grossly overemphasized by some agronomists. And I think the private agronomists that are pushing these things really need to have a good look at themselves in the mirror and say, am I really doing what's right? Is this really in the best interest of the farmer that I'm selling these products to? And so a couple of examples would be variable rate fertilizer technology. I think it's great, but it's being grossly over-promoted in some areas. Micronutrient fertilizers, there is a time and a place for them, but not at the level they're being promoted. So the way I see it, there's a great need for much better coordinated fertilizer research across Alberta, and we don't have that right now. So now I'm going to shift again and try to be more positive again, talk about soil conservation. I talked about the 1930s. Agricultural scientists, leading farmers really did a lot of very good work back in the 30s, but it didn't end there. There was people like Tracy Anderson, who worked at Lethbridge Research Station in the 1960s, doing direct seeding work before anybody else was even really thinking about it, other than a few forward-thinking scientists like Dr. Palmer. He retired, Tracy Anderson retired in the early 70s. Dr. Wainwall took up the charge, and he wasn't the only person, but he was a real leader in the shift and the research to do no-till direct seeding research. And he took that into the 70s and then into the 1980s. That's just a picture of Wayne taken in the 1980s. And really the goal was to look at trying to place fertilizer and seed into the soil with minimal disturbance, kind of leaving a thatch layer, leaving stubble up as much as possible, and disturbing the land as little as possible. And that was really the goal. And over time, we really saw that actually take place. And there were some very good leading edge farmers back in the early 1980s that listened to Wayne Lindwall and others and started to adopt direct seeding. And farmers like Ike Lanier, shown down here in the corner, farms in the Coaldale area. Another example would be Gordon Hilton, who farmed up in the Strathmore area. There were some leading edge farmers that were willing to take that risk and adopt some of this new technology. And it was a gamble. And they really learned how to adopt direct seeding. Looking at seeding equipment, and not just any in there, but looking at weed control, harvest management, straw management. It became a real system. And so when the leading edge farmers kind of learned how to do it right, and then by the 1990s there was much greater adoption. And today, more than 60% of Alberta farmers do direct seed, and most of Alberta's land is in a reduced tillage situation. So there's been a real evolution in agriculture in the last 30 years, shifting from conventional cultivated agriculture to direct seeding. And the benefits, well, definitely improve soil organic matter levels and improve soil quality. But when you have improved soil organic matter levels, that really increases the nutrient supplying power of soil. So for nitrogen and phosphorus and sulfur, that can be provided, and we can almost maybe in some cases even be, if you've been practicing direct seeding for 20 to 30 years, you could almost cut back on some of these nutrients now, just because the soils have that ability to churn and release these nutrients through mineralization. Other benefits, well, certainly that residue has really reduced soil erosion problems. That's also allowed us to store much more water in the soil. We've had higher precipitation in the last 20 years, it would seem, but because of soil conservation, we're able to store more moisture in the soil. That means greater crop diversity. We see a lot more diverse crops growing now than we did 30 years ago, partly just because we're actually storing more moisture and conserving more moisture. We've seen about a 70% reduction in summer fallow across southern Alberta, about a 3-fold increase in canola, and about a 10-fold increase in pulse crop production. So that move shift to direct seeding has also led to much greater crop diversity across not just southern Alberta, all of Alberta and the prairies. So comment number 9, prairie farmers have really excelled the adoption of direct seeding technology, which has really led to improved soil quality and increased crop productivity and crop diversity. So now I'll shift back to my negative phase again. So I'll keep going back and forth like I'm schizophrenic, which I am. But that's what happens when you work for the government for 38 years and you actually survive. If you're not nuts, you're dead. So, and I'd rather be. So one of my greatest concerns personally is the loss of agricultural land. We're seeing huge fragmentation of the land across Alberta, tremendous rural development. Some people think that's a good thing. Tremendous urban expansion, and our present government thinks expansion, growth is a good thing. I think modest growth is okay, but not at the rate we're going. And the result is the loss of some of our best agricultural lands. This is just a map that Rob Dunn gave me, just showing the rural residential footprint. Each one of these dots represents a country residential acreage. And you can see around Lethbridge, down around McGrath and Raymond. Whoops. Well, that's what I get for moving my finger around too much. I was maybe giving somebody my finger. Anyway, so here's Tabor, Medicine Hat, Brooks, but look at Calgary. Look at the influence of the area around Calgary. And keep in mind, some of our best agricultural land's right in this area in here. So what does really happen in Calgary? Well, to kind of stop back and think, when I was a kid in 1970, Calgary was 250,000 people. So 40 years later, where are we at? Well, Calgary is at about 1.1 million. So there was a four-fold growth, over a four-fold growth in Calgary in 40 years. When I was a kid in the 60s, we knew we were in Calgary. We're finally getting to Calgary because we got to the Chinook, so the Chinook Mall was on the edge of Calgary. Now you know you're getting close to downtown Calgary when you're driving past the Chinook Mall. So that's where we are now in terms of population. And if Calgary continues at a 3% growth rate right now, that means that in 37 years, in 2050, Calgary will be 3.8 million people. So what does that mean from a size standpoint? Well, that means Calgary right now occupies an area of just over 500 square kilometers. You think that's what they occupy now? That's a hell of a lot of land. But if there are 3.8 million, the prediction is that they will occupy 1,800 square kilometers of land. So here's Calgary. Here's the MD of Rocky View. There's Airdrie, Cochrane. Here's Okotoks and High River. If it continues to grow at 3%, that's what Calgary's going to look like in 2050, and I'll be about 98 years old then. And I still plan to be alive because I'm going to collect my government pension. I'm going to be like... that was more of a snicker from a lot of you people rather than a laugh. But anyway, but that's reality. Don Wentz is not laughing because he's sucking about 3 pensions up. So it's true. What can I say? Yeah, he's not on town council anymore, so he went from 4 down to 3. But anyway, we were really digressing. That's what happens when you have old your gray hair and I've got Alzheimer's disease, and I look out there and I see a lot of familiar faces, but I don't know who any of you are. And it's true too. Anyway, I'll smarten up and shut. No, I'm not going to shut up just yet. But here's Calgary right now, and this is what Calgary will look like. That's 1,800 square kilometers. So look at our Class 2 land, our best land, and in 37 years, which is not that long. Those of you that are young, when you're my age, that's what Calgary could potentially look like. And is that a good thing? Personally, I don't think so. So comment 10, urban sprawl, land fragmentation is really gobbling up a lot of Alberta's best agricultural lands. And fragmentation is segregating things even further. And in my mind, really society must really look at we really have to ask ourselves, how can we protect our land for future generations? And we really need to think long and hard about that. Now, the last one I'm going to talk about is I don't want you to think I'm down on the oil and gas industry, but we have to look at reality. We have to look at the positive and the negative. And the CAP always shows us these very positive commercials on TV, the great things they're doing. And they are doing some great things, but we have to look at the negative things that are going on too. We have to look at the things with our eyes wide open. We're blessed with great hydrocarbon reserves. But look at the number of abandoned wells that have accumulated in the last 100 years. This is work comes from Brad Stilfox. This is up to 2005. So we have on agricultural land over 120,000 wells that were abandoned, and that was out of 2005. It's much higher than that now, that need to be reclaimed. So we have extensive amount of land that have been negatively affected by the oil and gas from drilling, construction, and pipelines. So we have 120,000 wells or more that need to be reclaimed. We've got about 110,000 kilometers of pipeline installation of affected agricultural lands. And they make great claims on what a lovely job they're doing with the reclamation. Again, that is crap. You know, they strip the topsoil off, they set it aside, put it back and say, everything's wonderful. Well, you start talking to farmers, you can see a compressor station down here. This is a normal wheat growth here. And here's the right-of-way here where the topsoil was stripped off, the land was compacted, they did put on compost, they did a number of things. They're supposed to reclaim it back to at least 80% of productivity, in this particular case, not even 50%. And there's many, many, many miles of pipelines that have not been reclaimed properly. And that really takes a hit from a farmer standpoint, because the potential of that agricultural land, it could take 100 years to build it back up to the way it was. So drilling sites and pipelines have and continue to disturb agricultural land across Alberta. And these are questions I'm going to ask. I'm not telling you or the oil companies what they should be doing, but I asked the question, should drilling sites and pipelines have greater restrictions on the amount of land that can be disturbed in the various regions across Alberta? And should drilling sites and pipelines have higher reclamation standards? Right now, they only have to reclaim back to 80% of production potential. That's all they have to do. And personally, I think it should be higher than that. Now, I did have other issues I was going to talk about, like salinity, manure. There's other things I was going to talk about, but I thought, well, I promised Ken I wouldn't talk for too long, so I thought I would just kind of wrap it up. This is kind of my last comment. This is the only talk I'm doing in Alberta this winter. Lucky for you guys, but perhaps I just wanted to kind of look forward and just ask some questions about how should we be doing soil and crop research in the future. And all of you need technically advanced, unbiased soil and crop production information. It must be unbiased. There's too much biased information out there. And what can we do? Well, we have agencies like Alberta Agriculture doing some work. You have to keep in mind that half of our research staff was laid off in 2001. It's not well known. And almost all of our extension staff were laid off in 2001. But Alberta Agriculture is still doing some work. Agriculture and Agri-Food Canada have been just cut back substantially. They've been cut back from 500 to 300 scientists in the last 20 years, and the further cuts are on the way. So Ag Canada is being trimmed back. Universities, I just realized I spelled universities not right. But anyway, at least I don't have my reading glasses on, so it doesn't look right to me. But we have the University of Alberta, University of Saskatchewan, University of Manitoba. They're doing some good things, but they've been really cut back. There's a lot of other things that are more important in agricultural research. And in Alberta, we have a number of applied research associations, and we have various industries. And the one thing, my biggest criticism, is we don't work collectively to do work. We should be, we kind of try to, but we are very fragmented, and there's lots of little bits of stuff going on all across the province, but we don't see good coordinated cooperative research across the province. And collectively, we really need to move in that direction. And not only in Alberta, but I think collectively we should be doing it in Saskatchewan and Manitoba and have much better coordinated research. And then from there, if we have good information, then we can do the economics. We can do a much better job of extending information to farmers so they can get that good, reliable, unbiased information. There's too much biased information out there, in my opinion. So I'll give you my suggestion. We have Farming Smarter in Lethbridge, we have Alberta Agriculture in Lethbridge, and we have Ag Canada in Lethbridge. We have 3 different agencies doing bits and pieces for agronomy work. But collectively, I think we need to be working more closely together. We have our center at Brooks. It's very small, but I think we should put a lot more resources there so they can actually be doing more work in this region. And when I say doing work at Lethbridge, I'm not saying do work just on station like Ag Canada tends to do. We need to be doing work across all the agroecological areas across southern Alberta, from High River to Pincher Creek to Lethbridge over towards Medicine Hat. And Brooks needs to be doing this. We need to have a team of people doing that out of Brooks, a team of people doing that out of Airdrie, a team of people doing it out of Lacombe, out of CDC north of Edmonton, and then up in the Peace River region. So if we had about 6 different centers of excellence that could really focus on agronomic production that's coordinated amongst all of these different areas, I think that would be a giant step ahead. And have it under one umbrella group. I think that would be a huge step forward. And we would need to have at each location 1 or 2 research agronomists, a soil scientist, a plant pathologist, an entomologist, an ag economist, an extension agronomist that would work very cooperatively together. And they would have to have good support staff and top-notch field equipment, not just holding things together with binder twine. I got a kick out of that one slide that the one fellow from KMPG, is that the name of them, that they had at the end where he had an off-center balance weight on the back end. I was trying to put that politely, but that was actually Alberta Agriculture's tractor that we actually traded in last year. But we need to have, but at each center, then they could coordinate research specific to that region. They could do new crop development work, but then all of those different groups could be working together to do province-wide research when it needs to be done. And unfortunately, that's just not happening. It's very, very difficult to do a province-wide research. And I know that there was one fellow at Lethbridge who said he was doing province-wide research. He had a site at Lethbridge and a site at Lacombe. Well, that's not province-wide. That's just kind of getting warmed up. So in my mind, we do have good current agronomic information, but we're doing less and less coordinated research, and that needs to change. Collectively, researchers across the prairies, not just in Alberta, but across the prairies, we really need to be doing work in every major agroecological area across the prairies to conduct applied and adaptive agronomic research. And then, with that good information, then we can provide the top-notch recommendations to prairie farmers and industry agronomists. So my final comments then, the way I look at it, Alberta has 2 very, very important sustainable natural resources. And I'm talking about sustainable. Oil is not sustainable, but soil and water is. And water's been getting a lot of attention. Soil has been almost ignored by our province. And it's essential to produce food and to sustain our human life. And unfortunately, there's a real disconnect. If you talk to people in Calgary, or Edmonton, they have no clue where their food comes from. I have a couple of nephews in Edmonton, and they wouldn't know the back end of a horse from the front end of a cow. And I just think that that's really sad, and that's very typical of most of the people in Alberta now. So there's been a huge shift in people's knowledge and appreciation of the land and the appreciation of the soil to produce food. So my last comment then is soil and crop scientists and leading edge prairie farmers have made huge strides in the last 110 years to improve soil management and improve soil quality. But scientists and farmers need continued support. And society must pay much greater attention to the importance of agricultural land. Future generations, and I'm not talking 5 years and 10 years down the road, I'm talking about 100 years down the road and 200 years down the road, we're going to be needing our soils to not only produce food, we're going to need it to produce biofuels because most of our energy, our non-renewable energy sources will be gone, and to produce bioindustrial fibers and other necessities of life. We're going to need our land for many, many things. And if it's all paved over with concrete and asphalt, that's going to be kind of tough. So my concluding comment then is I think we really need to make huge efforts to conserve our soil and to preserve our land. So that's it from the old bastard. I wasn't going to swear, but anyway, if you have any questions, I'd be happy to address them. And as you know, I don't work for the Alberta government anymore, but if you ever want to get a hold of me, that's my home phone number and my home email. So that's it from the old guy.